Hello, good morning, one and all. Today's lecture is support vector mission. Um, uh, Before we starting the support vector mission, we start with the basic concepts of classification. So, what is the definition of classification? So, actually, the classification it is the process of classifying the given data set. So, simply we are categorizing what is the data you have. Uh, so, our data having different kind of classes. The classes may be the two classes or three classes or four classes. So these classes are classified according to the characteristics or the features of the data. So for example, there are the fish class is there, the bird class is there, and a dog class is there. So what are the features uh, they have? What are the features they have uh, of fish? Based on that, we classify all these data points are belongs to the fish class. So what are the data points are related to the dog class? So we classify those data members, the attributes as the dog class. So like that, we are classifying or the categorizing the given data set into classes. So in this process, you should consider the both structured data and unstructured data. So what is the meaning of structured data? The structured data means the data, the interrelationship between the data is meaningful. So you take a relational database management system. In this relational database management system, you are creating so many tables. You are performing some constraints on them. You are establishing some relations on them. So all these are called the structured database, the structured data. So then coming to the unstructured data, here the unstructured data means there is no relationship between any data points, so any data elements. So why? Because of in machine learning or the data mining process, you are collecting data from real world. You are collecting data from different organizations. You are collecting data from some websites like that. All these are not maintaining the universal structure, so that you have to collect the data, so the data in form of the unstructured. So the classification technique should classify both structured data and unstructured data. So in this process, we start with the predicting the class of a given data points. So we are taking some data points, we are performing the prediction. So based on this process, we classify the data. So here you take the decision tree. In this one of the basic classification technique is the decision tree. In the decision tree, the way of classifying in decision tree is the splitting the attribute space into different regions. Okay, so here what is but the first of all, what is attribute space? Here the attribute space is nothing but a set of attributes involved in the data point, in the data set. Okay, that is called attribute space. Okay, so in the decision tree, first of all, it is a supervised learning. The decision tree, the supervised learning. The supervised learning means before we starting the decision tree, first of all, we need some trained data set. So the trained data set contains both the attributes and along with the class. So based on that, we construct the decision tree. Here in the decision tree, actually you take one attribute, that attribute to split the entire data set, the entire data set, what are the data set you have into two regions or three regions. Again one region is again splitted with another attribute. Okay, based on that you take the one attribute and split the data set, and you take another attribute, you take and again you split it continuously, you performing so this splitting process, okay, according to certain parameters. Okay, so in this when the decision tree will stop, so there is no more splits. Okay, so that means all the classes are mm, all the classes are defined in the leaf node stages. Okay, so what are the nodes we have intermediately in decision tree? Those are called decision nodes. Okay, for example, you take this example. In this example, a company. So in this example, for example, you see a company, they want to classify their employees into two categories. This is the two class problem, two classes, that is fit class and unfit class. So how they classify them based on some attributes like their age, their the eating habits, and their the remaining habits like exercises, okay, whatever it may be. It is a very simple example. First they take the age less than 30. So you see, this is the region, the employees, so we have age less than 30, and this is the region, the employees who has age greater than or equals to 30. So actually here we have 1000 records. Based on this condition, the 1000 records are split into two categories. Okay, some records are belongs to this class, another class of records are belongs to this region. So again, you take another attribute, that is here they are using whether the employee is eating a lot of pizzas or not. If yes, so this region is divided into two parts. One is unfit class and fit class. So here this region of data set is again split into based on the exercise in the morning session. Based on that they are split into fit and unfit. So like this is the way to split the entire data set into different regions. This is very simplest manner. The decision tree is the easiest manner to express the data set in a graphical manner. Okay, then coming to the second classification technique is the Bayesian classifier. Okay, here the Bayesian classifier is a statistical classifier. Okay, the statistical classifier, so it means so it doesn't classify uh, a data point without any mathematical proofs. Okay, they have calculated the probability of that event occur based on the mathematical proof only. The base classifier classify that data point into particular class. It is very efficient manner, and then compared to the decision tree, because of everything you are calculating what is the high probability of a particular data point. Okay, is belongs to a particular class. Okay, so how the Bayesian classifier will work? So definitely it will work on some the conditional probability. Okay, so here I will explain some the conditional probability formula. Here you see, this is the heart of the Bayesian Here the Bayesian classification, the art of the Bayesian classification is its formula, that is the probability of x, okay, given the y. Here this probability, it is not a independent probability. So here the probability of x is, it is always the depending on the probability of y also. So this is one kind of the conditional probability. Here you want to calculate the probability of x given y. First we have to know what is the probability of y, the given x, and the probability of x. That can be divided by the probability of y. This is the Bayesian formula. So based on this formula, we are identifying the probability of the particular event. The particular the particular event occurrence, based on the occurrence, we are classifying that the data point into a particular class. This is the way we are classifying the data using the Bayes classification. And the third one is, before starting the support vector mission, first you have to know what is the difference between the decision classification and Bayes classification. Just I take one example. In the decision tree, it is a visualized representation of the classification method. In the Bayes classification, it is the statistical approach, but it is more accurate than decision tree, because of everything you are considering in the Bayes classification. Okay, there are so many factors are involved between the decision tree and Bayes classification differences. You have to learn, otherwise I can give one more video on the differences. Okay, the third classification technique is support vector mission. Yeah, in the next video, okay, I start the support vector mission. Okay, thank you.